from team Keep Learning. In this video, now we will see variations without repetition. In my previous video, we have seen variations with repetition, and now we will see variations without repetition. And it also comes under the broad umbrella of combinatorics. So just to recall you, I will one more time just describe the definition of what variations are. What variations are? The total number of ways we can pick and arrange some elements of a given set. The total number of ways we can pick and arrange some elements of a given set. So some objects are given to you, some kind of task is given to you, you have to fill some slots and you have some options. So in how many varied ways you can do that you find in variations. And while doing so, sometimes you may be allowed with repetition and sometimes you may not be allowed with repetition. So with repetition we have seen in my previous video, and now in this video we will see how to go ahead with that when no repetition is allowed, that is without repetition, variations without repetition. Let's start. So suppose there is one coach and he wants 4 members for a certain task. But there are 5 eligible candidates out of which he has to choose 4: Tom, Eric, David, Kevin and Josh. So out of these 5 eligible candidates he has to choose 4. Okay, now we will see how he will be proceeding in his task. Suppose he is filling the first post. First post. So for the first one, he will have 5 options. Okay, because there are 5 eligible candidates. So for the first post, he will have 5 options. Suppose he chose David. Suppose he has chosen David. So now for the second one, he will have remaining 4: Tom, Eric, Kevin or Josh. Tom, Eric, Kevin or Josh. Suppose on the second one, he has chosen Josh. So for the third one, options left with him will be Tom, Eric and Kevin. And if suppose he has chosen Kevin, for the last one he will have either Tom or Eric. So what does it means? The further down the order we go, the fewer options we are left with, because at first place we have 5 options. Then for the second place 4, then 3 and 2. That means here he has 5 options, then 4, then 3 and 2. So if I multiply all this, it will be 120. So he has 120 different options of how to arrange our team for the competition. That means 4 spots out of 5 candidates. Okay, now we will go further in this. How to calculate the same using mathematical formula? So the formula goes like this: v raised to the power n equal to factorial n divided by n minus p factorial. N divided by n minus p factorial. So the number of variations without repetition when arranging p elements out of a total of n. Okay, when we are arranging p elements out of a total of n. In my previous video also we had 3 options available, A, B and C, and the spots we need to fill was 2. But there repetition was allowed. If you have chosen A for the first bar, you could choose A again for the second bar. But here this is not the case. If you have taken at first place someone, you cannot take the same person at the second position, because the person is one only. Okay, so the formula is factorial n upon factorial n minus p, the number of variations without repetition when arranging p elements out of a total of n. Now we will put all these things in the formula. So v4 raised to the power 5 equal to factorial 5 upon 5 minus 4 factorial. So factorial 5 upon factorial 120. And same is the case when we calculated by ourselves, it was 120 only, 5 into 4 into 3 into 2. And with this formula we calculated, it is 120. Here p is 4 and n is 5. So I hope this formula for variations without repetition is clear to you. We are doing nothing but just we are subtracting p again. Why? Because it is not allowed again. It is not allowed again simply to say it is without repetition. That's why we are subtracting p from the denominator, and this is how variations without repetition is calculated. So I hope it is clear to you. If you have any feedback, any doubt, or if you would like to make any suggestion, kindly direct it on this mail, or you can comment it in the comment box below. Thank you.